And welcome back. Now, it's probably the magnetic topic that has attracted you to this particular video because it's all about magnetism and magnetic fields. Because a Hall effect transistor, which is what that little tiny thing is here on the circuit board, is all about. And Hall effect transistors detect magnets. Now, I have a magnet on the end of my probe here, and as you can see, there's a little arrow on it. And that is important because the polarity of the magnetic field is what the Hall effect transistor detects. So if I bring this close, as you can see there, look, the red light at the back goes on, showing that this transistor is actually conducting, and then of course the Arduino is connected also to that point and is then turning on this Christmas tree type light. So bring that nice and close and you can see off it goes, and it's fairly quick as well, or very quick in fact, as you go backwards and forwards. Now, incidentally, did you know that blue tack is also magnetic in its property? You can just roll a piece of blue tack near it, that'll turn it on and off. See, that's pretty neat, eh? This is proper blue tack, by the way. Doesn't always work, right? You have to sort of, yeah, it does now. This is Bostik blue tack, so it is the real stuff. I've tried other stuff and it just doesn't have the same effect. See, there we are. That's quite interesting. So I've got this. Oh, that's ruined it a bit, hasn't it? Oh, all right then. Okay, I've buried a magnet inside here. Yes, all right. It was a little bit of a joke, but that sort of gave it away, didn't it? Well, we're going to need this little magnet inside here because I've got at the back there and a spinning washer with one magnet on it. But I'm going to put another one on just to balance it, to show you that if this were a wheel on a model car or something like that, or even a robot of some kind, you could easily detect the speed of a wheel as it goes round. So as it goes round, it obviously makes and breaks the circuit. Let me just get a little bit more close. There we are. So as I spin that, it's flashing the light. Especially look at the red light at the back, because that's the one that gets turned on by the actual Hall effect transistor. This thing is a little bit slow because it gets turned on with the Arduino. It's one of those Christmas tree lights as well. So it's got a chip inside. So as I spin that, you can see that it does, every time one of the magnets goes past, it turns on and off. And the frequency response of this transistor here is fast enough to detect any revolutions of a model car. Now, I think you need to see the circuit diagram of this, which is simplicity itself. So let me just show you that first, and then we'll just talk about a couple of other things about Hall effect transistors. Right, see you in a bit. So the 3114 Hall effect transistor has only got 3 connections. Let's draw that first. The first one goes to positive, the middle one goes to ground, and the third one, remember, is the open collector to which you have to supply currents. Let's have a little resistor and an LED coming in there, and that's also the point where we detect stuff from the Uno, and that's our output from the Uno, pin 8. Well, there's not really much to it, is there really? Just don't forget that if you didn't want an LED there, just put a 10k resistor in, that'd be absolutely fine. Right, so that was the circuit, and as you saw, it really was simple. Now, the thing about Hall effect transistors is that they are polarity dependent. So if you have a magnet and you don't know which pole is north and which pole is south, here's a little trick that you can use. Let me just zoom in on that so you can see how tiny it is. I can't quite remember what shape that's called, but we'll have a look in a minute on the data sheet. Now, as you noticed on this magnet I've got here stuck on the end of my probe, there's an arrow on it because that direction is in fact north. So north works, but if I take it off and turn it around the other way, like so, as you can see, nothing happens at all. I can go up to touch it. So it is very much direction dependent. Now, if you had 2 of these detectors, Hall effect detectors, plugged in here, as I have, but you didn't know which polarity was which, you could easily make a little circuit to detect which one was detecting it, because if you do it from the other side, nothing happens. So if I turn it round, the magnet that is, right, there we are, see, now it detects the south pole. So they are aligned. It's even attracting that LED look. Oh, blimey, these are strong, these little mini magnets I've got here. You can buy these incidentally on eBay for well, very little money, but they are very, very powerful. What are they, neodymium or neodymium magnets? Some rare earth metal anyway. So let me just set that back the way it should be. So if you had two of these Hall effect transistors, one facing this way, one facing the other way, then you could bring any magnet to it and it would show you which way was north and which way was south, wouldn't it? That's not probably the primary use of these transistors. They're probably used in alarms, for one thing, rather than a reed relay, which is just a switch actuated by a magnet. This is a bit more, I don't know, electronic, isn't it? No moving parts. That should last, well, pretty much forever, I would have thought. And of course the spinning wheel thing. Now if I do this really slowly, you'll see the effect of it probably better as each wheel turns. Hello, does that one not? Oh, that's interesting. Look, we've got one of the magnets back to front. That's why it doesn't light up so often. So let me just turn that one the other way round. That was the one that was buried in that load of blue tack. Does that work now? Right, that's better. So now that works as well. So as I bring round the next one, yeah, that one also works. It's a bit difficult doing this on camera because I've either got to look down at my circuit board to get it all lined up, in which case you'll just see the top of my head. So let me take myself off camera. There we are. Now I can get it all nicely lined up. So there we are. It's detecting it, and again, and again, and again. Now I can do this, you know, umpteen times a second, so that if you have a model car or whatever it is, you've got a motor, anything really, you could detect that. And well, almost like a stepper motor really, couldn't you? You could have this, have the motor controlled by the Arduino, and hence use a Hall effect transistor to detect where the end stop was. Now if you think back, well, several months ago now in fact, to a project I did that used a stepper motor to detect the temperature, and I used it with a little arrow on it and everything else with a 3D printed part. Yes, that one on screen now. That was an interesting little project, and it's still hanging up in my workshop downstairs, and it works very well. But as I said, had I known the difficulty with that micro switch, I most definitely would have used one of these, and these are cheap. So let's have a look at the data sheet first, then we'll have a look about where all these parts came from. Well, the part. I just thought I bought lots of them. Right, the data sheet first. Here we are. Now the first thing you'll notice, oh by the way, the part I've actually got is an A3144. I don't really know what the differences are between these other ones. It does describe it in the sheet here, but I can't remember. Now the first thing you'll see, of course, is it's a discontinued product. You think, oh well, things do go out of date, but look at the date. The date is October 31st 2005. That's almost exactly 11 years ago, and here they are, still available on eBay or wherever it is you want to buy them for. And they are literally, well, 10 a penny. So what does it show you? Well, there's the little circuit diagram, or the representative circuit diagram inside. Only 3 connections, of course: supply, ground and output. So that's simplicity itself, as you saw in the circuit diagram. They work at various temperatures. Here's the absolute maximum ratings. I couldn't find though the maximum frequency. So when we have a motor with the 2 magnets on, like I showed you there, I'm not totally sure how fast that can go before the Hall effect transistor wouldn't work, because it does have a certain type of hysteresis, which means the switch on and switch off points are different. Let me demonstrate. If I bring the magnet close, and I'm going to do this really slowly so you'll see when it actually there. So it's on at that point, but now I can look, I can bring it back further than when it went on before it switches off again. And that little bit of free play in there that I'm doing there now, that's what's known as hysteresis, and stops it sort of in that on off mode. You're either on and then it's got a little bit of leeway, or you're off and it's got a little bit of leeway to move. And you probably want that for all sorts of things, whether it's detecting spinning wheels or, I don't know, shop doors opening, if you can use it for that. You don't want it at the point where it constantly flickers on and off, you know, like that. If you got it to the point where you know, it was just half on, half off, and it kept flickering between the two, you don't want that. You definitely want it either on fully and then it's got a bit of leeway with the movement, or off fully and it's got a bit of leeway with the movement. Okay, that's the hysteresis. But as I say, I was trying to find out the frequency at which we could run something past. Oh, they're all sticking together. Run something past this before it decided that in fact one pulse was blurring into the next, but I couldn't find anything, to be quite honest. So anyway, back to the data sheet and see what else we can find. 28 volts maximum supply, reverse voltage minus 35. I mean, these are all excellent for Arduino use, even if you went up to 12 volts or even 24, you're still okay. Yes, now the continuous output current is only 25 milliamps, so don't go mad on this. You probably want to drive either an Arduino with a resistor, as I've done on the circuit here, or use a transistor to generate something else. I suspect though that you'll probably be using this as a detector, so very low current, and the Arduino as the logic and switching unit. Certainly that's the way I'd do it. Right, what else does it say? Now there's the functional block diagram. So we only have the three connections. As I say, we have the positive here, ground down the bottom, and then an open collector. So you supply power in via this, as you saw that on the circuit diagram. I mean, how all this bit works in the middle, who knows, frankly. I don't, that's for sure. Right, so supply voltage is 4.5 to 24 volts, nice wide range, that's excellent. Saturation voltage, well, we're not really worried about that, are we? That's no, don't care about that. Leakage is tiny. Supply current 4.4 milliamps. It's low. I'd have liked it to be a lot lower than that. Output rise time 0.04 microseconds and fall time 0.1. Now actually, if I was a bit better at maths, we could probably work out the maximum frequency it could use with those values. But I reckon even a high revolution motor, you know, 2,000–3,000 RPM, would easily be detected by this. I can't believe it wouldn't be. Magnetic characteristics, I don't really know what this is telling me. I don't really understand all this. And as Arduino users, we don't really care that much, do we? And if you've got that detailed a requirement, then you probably do understand all this and can make head or tail of it. What else? Switch points. Oh, here we are. Now, this is the hysteresis I was telling you about. So it switches in at one point and releases at another. And this bit in the middle, that's the gap. That's the hysteresis where it's either on or it's off, but it will maintain that state, which is good for us. Supply current, okay, we've already mentioned that was very low, and 25 milliamps maximum, of course. I guess that's about it. There's a little bit more information here, but we don't want to go too mad. That's all about physical characteristics. So if you're building a million of these, you probably do want to know. Oh, well, there's a bit more detail here about the individual parts. So I've got a 3144, and it just tells you a bit what it does here. I'm not too bothered about that. I don't think anybody else would be either. Right, that's that. So now what you probably do want to know is where did I get them from and how much are they? Are they £1 a piece or whatever? So let's go over to eBay. Let me just take myself off the picture here. Right, let's go over to eBay and find out. Right, so this is a UK supplier. Now he was selling 10 pieces for £3.79, which turns out to be 38 pence a unit, as it says here. That was I can't even pronounce that. Actually, Country UK, but they came pretty quick, as you'd expect, and it does say, look, 3144 on them. That's fine, but you can buy them an awful lot cheaper than that if you're prepared to wait a little while. Here's somebody else on eBay. Who's that? Digital Paradise 9, and you get 10 3144s for 99 pence. So that's 10p a unit, isn't it? So if you've got a project coming up, it's always best to plan ahead and buy cheap, really, isn't it? I think they're pretty much the same. Yep, there we are, look, exactly the same. You can just make out the markings on there. So that's where you can get them from, either the UK, and of course if you're in the US, they're bound to, ebay.com is bound to have, well, certainly this seller on it, I would think, and you've probably got some local ones as well. The only reason I'd buy this locally is if I wanted it, like, you know, the next day or two. And that's about it, really. Okay. Right, so that's where I got those from. And back to the workbench now. We'll just talk about a couple of other things. As you can see from the circuit, this is all wired up so that I've got the output from the Arduino. I'm going to have to use the other end. Right, the output from the Arduino is coming from pin 8, I believe it is, or 9, wherever it is anyway. And that's fine. Now just imagine for a minute that you were building a project like this, or you already had built a project of some kind, and all you wanted was one more pin like that, well, say to connect up a Hall effect transistor. And you think, oh, I've used up all my digital pins, right round down from D0, which you should never use, of course, or D1, because they're the USB input outputs. But anyway, let's assume you'd used them all up from D0 all the way up to D13, and you were desperate for some more outputs. It would be nice, wouldn't it, if you could just unplug it from D13 and, I don't know, stick it into something like an analog input, which is like that one there, A0. Now, if we could do that, of course, you'd suddenly have a whole 7 pins extra to play with. So what we really... Oh, look, it is working. Look at that, we've put it into A0, and yet the output, that one over here, is still coming on as it should do. Why is that? Well, I just thought I'd mention, in fact, that analog inputs can be used as digital outputs. And quite a few noobs forget that. Yes, they're called analog because they're the only pins that can actually read and write analog values. So you read an analog value from 0 to 1023 and you can write it out from 0 to 255. But you can always make those pins output pins as well. And in fact, you can switch the pins use on the fly. So whereas on here, obviously the sketch is pre-prepared to do this, it's setting that A0 to an output pin. But I could, as part of the logic, set that pin back to an input to read a value. Now the only caveat there is you can't switch it from an output back to an input, or from an input to an output too quickly, or you'll get a false reading. So if it's already an output, you can switch it to an input and then just delay a little bit, or wait, or do something else during that little period, and then it will work as you'd expect. Okay, in fact, that is mentioned on the Arduino playground, maybe somewhere. We'll have a look in a minute. So let's have a look at the sketch now, which is simplicity itself, where I've already done all this mucking about with A0. Let me just load that up and we'll have a look. Right, here's the code, and as you can see, it's a pretty simple piece of coding, and that's with me mucking about with the analog pin as well. So what we've got here then, we're saying the detection pin is pin 6. That's the output from the or the collector point of the Hall effect transistor, where we've supplied the current from a resistor, and we've got two outputs, LED pin 8 and A0, or at least we've defined them here. And here, look, we're making them both outputs. So the detection pin is an input with an input pull-up. You must have a pull-up. And the outputs are just defined as you would normally. And basically what we're saying is, if the voltage at that pin is high, it means there is nothing been detected by the Hall effect transistor, the 3144. So the LEDs go low, or LED, it's the single one. And if it is low, that means that something has been detected, so we'll make it go high. And that's all there is to it. So as you can see, you can create an A0 as an output quite happily, and it's all very, what's the word? It's acknowledged as being best practice. It's designed to work like that. So it's not like we're doing something we shouldn't be doing. It works as you would expect. Just press the wrong button. Here we are. Right, just to prove it again. There it is, all happily running from A0. And you can see it's A0 because that's where the origin cable is connected over here. Look. Right, so that's great. Now there's one little final thing, talking about more pins. So let's say we used up all these pins down here in a project, and we'd use, for whatever goodness knows reason, all the analog pins as well, from A0 to A7. And we're thinking, if only I could get some more pins. Well, if you've watched a previous video of mine, you'd probably be now thinking, I know, I2C pin expander. Yes, you could. That's perfectly logical and probably what I would do, quite frankly. But there is now a new board out. Well, I say a new board. It's a board by another manufacturer that actually gives us some more pins. So let's just have a quick look at that. So as you can see here, this is a Uno compatible board by RobotDin. And the thing about it is that it's got extra A6, A7 pins, so it's extra couple on there. Now the Nano also gives you a couple of extra pins, I can't remember how many, but if you're after a Uno that has extra pins, then this is probably it. Now this one is £2.22. Now that's from AliExpress, which unfortunately doesn't offer PayPal, so that sort of precludes it for me. But on eBay itself, it's a bit more expensive. So eBay, the cheapest I can find it anyway, is £4.69, which of course, given what it's offering you, is quite amazing. But it does give you the A6, A7 there. Look at the back, you can just see them there at right angles to the original A0 to A6. So that's an extra couple of pins as well if you were really desperate, although personally I think I'd probably use a pin extender at that point. Okay, right, that was it then. Thanks for watching the video, and we'll come back with some more interesting facts in the next one. Okay, thanks for watching. See you in the next video. I hope you're finding these videos useful and interesting. Please leave comments down below, subscribe, share, and give me a thumbs up. Thanks for watching. See you in the next video.